Hello there, and welcome to Chapter 3, Section 2. We're talking about something called rational numbers. You're going to love this because it's going to be decimals and fractions. Ooh, scary. I know. Let's jump right into things here. First word here. Actually, if you have not done this yet, put your name on it. And the date would be good too, because you want this to be placed in your binder by date. And our first word here is rational numbers, just like its title. Rational numbers, that's our first vocabulary. If you're a highlighter, that would be what you want to highlight right there. Well, this sounds way more confusing than it really is, but we'll read through it here. Rational number is a number that can be written in the form of a over b. So basically it can be written in the form of a fraction. Now there are numbers that actually can't be written as fractions, and those are not rational numbers, but we'll look at those later. A and b are integers, and b does not equal 0. That's just talking about this fraction here, that a is some number and b is over some number b. All right, well, the easiest way to figure out if a number is rational is there's basically two tests that must be true. One of these two tests must be true. Okay, so rational numbers must have one of two qualities when written as a decimal. Okay, so the easiest way for you to figure out if a number is rational is going to be to see if one of these two things is true. Either one, just one, and it's rational. All right, the first one is that it's terminating. In other words, that means that the number ends. It has an ending point, such as this could just be a regular number, like the number 7, or my favorite number 9. Those are numbers that terminate. They stop at the decimal point. So any number, it could be a negative number, like -3. These are all rational. Okay, if it ends, it's rational. It could be a decimal like this. It could be like 1.253, and then it stops. All right, that terminates. That terminates. So that means it's rational because it stopped. It had an ending point. So any kind of decimal that -3.75, there's one. That's a terminating decimal. It ends. Okay, so if it ends, it's rational. It's in the group of rational numbers. So it does include all the integers that we've talked about up to this point. Now there's another one that we haven't talked about very much, and that's called a repeating decimal. Now this would be a decimal value that you see a pattern that repeats over and over and over again. A very simple one might just be, let's just say we had 0.999, and that goes on and on forever. Okay, so that's a repeating decimal. So those are also rational. Okay, so these are rational. If it terminates or it repeats. Now I should add that if you have 0.9 repeating like this, we write that repeating symbol like this. If you find the value that's repeating, which is the 9, and you just put a line over 1,9, that means that 9 goes again and again and again. And we can use this in various ways, such as let's say I had this strange one like 125, 125, 125. And let's say that pattern went on forever and ever. Okay, you take what repeats, 125, and you just put it down once, and you put a line over it. That means that repeats again and again. Here's a really strange one. Let's say I have like 1.755, I'm just making it up, 5, and let's say the 5 repeats there. How do you think you'd write that? You want to guess? Did you say 1.75 with a line only over the 5? Because the 5 is what's doing the repeating there. Okay, 1.75 repeating. But not over the 1 and the 7, because the 1 and the 7 are not repeating. All right, so those are all rational numbers for you there. Okay, now let's take a look at the bottom half of this page. It looks a little confusing, so I'm going to talk you through it. Then I'll probably stop the video and start again because I'm going to explain this to you, and I think I have a better visual. But this is right out of the book, and I just wanted you to be aware of it. This is some vocabulary of rational numbers. All right, when you first learn to count, I'm reading it here. First learn to count using the numbers 1, 2, 3, 4. You were using members of the set natural numbers. So 1, 2, 3, 4, that is the set of natural numbers. Starts at 1, does not include 0. Okay? Now, so that's like the first part. 1, natural numbers. All right, 2, here's the second part. All right, if you add 0 to the set of natural numbers, the result is a set of whole numbers. Okay? And whole numbers include, sorry, I'm trying to reset my highlighter here because I don't like how fat it is. There we go. Whole numbers include 0 and include all the natural numbers as well. All right? And then the third thing that you'll need to know is when we throw in negative numbers. Now, we've talked about this. In fact, one day you all came up and wrote numbers on the board, and you said an example of an integer is, and then you gave me an example of a non-integer. Integers include all the negative numbers and all the positive whole numbers. Okay, but integers do not include decimals there. Okay, only whole numbers or negative whole numbers. All right, it's when we get to the fourth word, rational, that's where we can include the decimal values, fractional values. Okay, now notice this decimal here, this 0.87, that terminates. Look at this negative 2.56, the 5 and 6 repeat right there. Or if it can be written as a fraction, it's also rational. Okay, because if it can be written as a fraction, it will eventually stop or terminate, one or the other. Even though it might not look like it on your calculator, it will if it's a real fraction. It's a fraction. So there we go. Okay, so this video, I'm going to stop here because I'm going to need a full video, I think, for my next part that I want to do. So there we go. First video under 8 minutes. Not too bad. Okay, so make sure you're hitting pause as you go through this or going back and reviewing anything you need clarification on. And that's all I have to say.